Lesson 4, probabilities using counting methods. So when you have questions that are using counting methods, don't forget the last 2 units that we've done. Use that knowledge to help you solve your problem. So you usually want to look for your total possible outcomes, so how many possible outcomes there are, and how many possible outcomes the event you're looking for can happen. So, example 1, Jamal, Ethan, and Alberto are competing with 7 other boys to be on their school cross-country team. All the boys have an equal chance of winning the trial. Determine the probability that Jamal, Ethan, and Alberto will place first, second, and third in any order. So first of all, we think about how many total racers there are. And there's 7 and plus the 3 boys, so there's 10 racers. We know we want to choose 3 of them to be first, second, and third. So the total outcomes would be 10, and we want to pick 3 of them because the order does matter if they're in first, in second, or in third. So we would solve for this, so we remember that it's 10 factorial divided by 10 minus 3 factorial, which is 10 times 9 times 8 times 7 factorial divided by 7 factorial. So we're left with 10 times 9 times 8, which is 720. So there's 720 possible outcomes. We want to see when Jamal, Alberto, and Ethan win. So we want to take 3 and pick 3 of them. So that would be the same as 3 factorial over 3 minus 3 factorial, which is just 3 factorial, which is 6. So there's 6 possible ways that those 3 boys can win. And if you were to think about it, we could have Jamal win, Ethan get second, Alberto get third, Jamal could get first, Alberto could get second, Ethan could get third, and then we can split it all up again. So we could go A, E, J, A, J, E, and we go E, A, J, and E, J, E. So that is the 6 possible ways that those 3 boys could get first, second, and third. So we want to find the probability that they'll win, which would be 6 out of 720, which is, if you simplified that, would be 1 over 120. Divide the top by the bottom, times by 100. And you'd get 0.83%. So there's only a 0.83% chance that that will actually happen, that those 3 boys will get first, second, or third. A husband and wife meet a group of people and introduce their 2 daughters. They then explain how they have 3 other children at home. Determine the probability that at least one of those children is a boy. So they've got 3 children. And there's 2 possible outcomes for each. They could either be a boy or a girl, a boy or a girl, or a boy and a girl. So altogether we have 2 times 2 times 2, which is 8 total outcomes. So there's 8 different ways they could have kids. They could have a boy and 2 girls, a boy and a girl and a boy, who knows. But they have 8 ways that they can have children. So we want to determine the probability that at least one of those children is a boy. So what we need to figure out is the probability that they are all girls. Because if there's at least one boy, it cannot be the probability that it's all girls. So the probability that it was all girls would be 1 times 1 times 1. There's one way that they can have all girls. So the probability of the girls would be the favorable outcomes, which is 1, over the total possible outcomes, which is 8. So they have a 1 in 8 chance of it being a girl. If we wanted to find at least one boy, it would be 1 minus 1 over 8. So that would be the same as 100% minus 1 over 8. which is 7 out of 8. So there's a 7 out of 8 chance that at least one of those is a boy, and that probability as a percent is 87.5%. There's an 87.5% chance that they have at least a boy. You have 12 tiles that spell out the word Saskatchewan. You want to place the tiles upside down and mix them up and rearrange them into a row. Determine the probability that when you flip the tiles back over, you spell the word Saskatchewan again. So first we want to do the total outcomes. So we want to figure out how many ways we could rearrange Saskatchewan. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. So there's 12 factorial. But because our A's repeat and our S's repeat, we have to divide by those numbers. So we know there's 2 S's, so we divide by 2 factorial. And there's 1, 2, 3 A's, so we divide by 3 factorial. So we have 12 factorial divided by 3 factorial divided by 2 factorial is 39,916,800. So these are the total outcomes. Now we want to figure out our favorable outcomes. And Saskatchewan can only be spelled in one way. So our favorable outcome is 1. We want to get it back where it started. And because we don't care if things repeat, there's only one way to do that. So the probability of spelling the word is 1 over 39,916,800, which is, times it by 100, is 0.000025%. So there's a very, very, very small chance that that would actually happen. Example 4, there are 18 bikes in a spinning class. They're arranged in 3 rows with 6 bikes in each row. 6 friends take the spin class, 4 of them are women and 2 of them are men, and they want to be in the same row but cannot request which bike they will use. Determine the probability that the 6 friends would be in the same row with 2 men at either end. So altogether, there's 18 bikes. So the total ways people can sit would be 18 factorial. There's that many ways that the people can sit, which is 13,366,080. Now we want to figure out how the 6 friends can sit together, where they have the men on the outside and the women on the inside. So because the men are on the outside, they can sit in 2 times 1 ways. And we can express that as 2 pick 2 for the outside. Then we have to look at the inside. So we have 4 times 3 times 2 times 1. So the inside people, we do 4 pick 4. The rest of the class all has to be sitting down somewhere. So the rest of the class would be 18 minus the 6 friends, which is 12 people in the class. So we would have to arrange the other people in pick 12 ways. So that is how the rest of the class would sit. Now, because there's more than 1 row, and there's actually 3 different rows, this could happen 3 different ways. They could either be in row 1, row 2, or row 3. So this would be our equation to figure out our favorable outcomes. So we're going to type all that in, and you should get 144 different outcomes. So there's 144 ways they can sit with 2 guys on the outside, 4 girls on the inside, and all in the same row. So the probability for the friends to sit together is 144 over 133,66080. Divide those numbers, times by 100, and you get 0.001% chance. So there's a very, 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 very small chance that they can't sit with them. It's like Mean Girls. You can't sit with us.